Thank you. So thank you for the invitation to be here. Thank you, and for a delicious meal last night. It was wonderful. Um, uh, it's a great pleasure to be back at IWA. I think I was last here in 2000. Some of you weren't born in 2000, I guess. I feel like I was born a long time before then. So I'm very sorry that your director is not here. I'm sure she'd be delighted to be to see this come to fruition. And thank you for the dean for her welcome. I understand that she's been dean for a month, so I can sympathise how what it's like. So I'm going to the slides you have in the book are not the latest version, so I've added some. So and there's also a little quiz later, so don't look ahead, otherwise you'll be cheating. And what I'm going to try and do is to reflect on some ideas I had 25 years ago, really, and see how they've evolved over time. But I'll start by just showing you where I work. I'm sure some of you will have been to London, will have been to the Institute of Education. Many years ago, the Institute of Education was a separate college of the University of London, and now it has been integrated, taken over, if you like, by University College London, which is now the largest university in the UK, with about 50 or 55,000 students. We have in the Institute of Education, we have, I think, 7,000 or 8,000 students. It depends on how many people turn up on the first day of term, which for many people is next week. I work partly on master's programs, partly on PhD programs. I do some research, and part of my time is spent with our Centre for Climate Change and Sustainability Education. We have a website at the moment. It will be changing soon. We're going to a more friendly site for it. So if you look at it now, it's not wonderful, but it will evolve in the next month or two, and the resources will be much more easily available. We do three things. We run a professional development program for teachers, which we call Teaching for Sustainable Futures. And that is primarily, we produce online materials which last about an hour for teachers from different subjects to help them to sort of adjust their lessons so that they are able to incorporate more sustainability teaching in their subject, whether it's primary or secondary, with geography or history, mathematics, English, whatever. The second thing we do is we produce research reports, so we carry out research, and I will show you some of this research later on. We research into teachers' and students' views and other things. And we also try and have a policy dimension. We try and influence policy. So our government has commissioned a review of the national curriculum in England and a review of the assessment system. And we are hoping to be able to influence that review to get more climate change education, more sustainability education into the national curriculum. And we are optimistic there will be some changes. So just about 4 weeks ago, I was in Greenland. This is just the third, near the third largest city in Greenland, Ilulissat. Greenland has been in the news because some people in America want to take it over, make it an American state. Well, it's the first time I've been. It's about 21 times bigger than South Korea, and it has a population of about 60,000 people. So it has a vast size, a small population. There are far more tourists and visitors than there are native people who live there. And of course, it is covered, 80% of Greenland is covered by ice. The ice ranges from, it's on average 1 kilometre thick, but sometimes it's 3 kilometres thick. And 80% of the country is covered in this ice shield, which is slowly melting. And at the moment, it's melting faster than the snow is compacting on top. So in about 15 to 20 years, a lot of this ice shield may well not be there. So this is, you talked earlier about climate change and its influence on our society. This is, for me, a breathtaking example of the impact of climate change on this pristine, almost pristine environment. It's only when you go to a place that you realise that the magnitude of the problems that face us. What was an interesting issue while I was there was that many of the local people who work in the airport security are Inuit people. They are people who've lived there for generations. And on August the 1st, it's the first day of the reindeer hunting season, which lasts until the end of August, until September, October. And so many of the airport security staff did not turn up for work because they had gone to shoot reindeer. And it's an interesting clash of indigenous Inuit behaviour and priorities, and the sort of the more westernised, modernised, maybe demand for people to do security jobs. So flights were delayed because people were out shooting reindeer. And I have to say, it's the first time I've experienced that as an excuse for a delayed flight. Climate change, of course, is one of those problems, one of these problems which we call wicked problems. Wicked problems are problems that cannot be solved. They are problems that we may have known about for a long time. We may only just be discovering them, but they've been around for a very long time. They are not in any way soluble. We just have to adapt to the fact that they are there, and we have to find ways to mitigate the impact of those problems. So we know that climate change will not go away. We know that poverty will in some way not go away. We just have to adapt society to compensate for it. So the idea that education, when I was a teacher in school, the idea was that we taught children problem-solving skills. Problem-solving skills are not enough to deal with the wicked problems that face us. We have to teach people new ideas, new ways of thinking about how to address these insoluble problems. Just to give you a more contemporary, more locally based problem, this is from the Guardian newspaper. It's from a few days ago, 31st of August, and it's a story of a baby who died a few months ago in June, I think, because they died of a rare disease, what was a disease that we thought we had eradicated, whooping cough. It's a very easily passed on disease from mothers to children, and neither the mother nor the baby had been vaccinated. They had decided not to vaccinate the child. They decided not to be, and the child died. Now, this situation is increasingly common in the UK and other countries. It's not as bad in the UK as it is in some other countries, but we're living in a society, a set of societies where we are less able, science is less able to influence the public in ways that actually will protect them. There are people out there, some social media, politicians, who for some reason deny scientific evidence, who deny the scientific consensus about vaccination, about all sorts of other issues, and it is a major problem facing society, and it's a major problem facing all of us who are working in science education, environmental education, disaster risk education, hazard literacy, and so on. And we have to readjust what we're doing in order to cope with the current lack of trust in science and scientists. In this paper, in the journal Education and Chemistry, I and a colleague, Lucy Avramidou, made a shorthand version of a paper that we'd written in this Journal for Activism and Science, Technology Education, where we were reflecting during the COVID times. We were reflecting on how the science education community was responding to COVID. And we were writing at a time when we were on lockdown. We were writing at a time when science education, the community did not seem to be doing anything to respond to the fact that clearly, in our view, science education had failed. And we say that, it's quite maybe a bold statement. We asked a series of questions. One of the questions was this one here. To what extent is there any evidence that the science curriculum has prepared the world's public for COVID-19? And the answer seems to be there is very little evidence. A lot of people were unable to tell the difference between viruses and bacteria. People did not understand how the masks worked. People did not understand why washing your hands was, and so on, and so on, and so on. And these are people who have had 10, 12, 15 years of science education, did not understand the science that could keep them alive. And people died because they hadn't been educated properly in science education. And that reflects badly on the science curriculum, science education policymakers, and I'm afraid people like ourselves who haven't been promoting the right kind of science education. And it's not just COVID. If you look around the world, there are people who do not believe that humans landed on the moon. Some people believe the Earth is flat. Having flown for 12 hours yesterday, I'm convinced it's not flat. But then, there are people who believe that airlines are pumping poisonous gas into the atmosphere. There are people who believe that your telephone will give you cancer. There are people, and so on and so on. And all this is being fed by experts on the internet who provide all sorts of conspiracy theories. And the sad things is, and the difficult to understand things, that so many people will believe them. People are so distrustful of institutions, universities, scientists, scientific organisations, governments, whatever, sometimes understandably, but we are faced with a situation where we can't assume that people will trust scientists, people will trust scientific institutions, and we have to rethink science and environmental education generally to address these issues. Here's an example from the US. It's a pharmacist, someone who had a professional training in science at a very high level, was caught destroying vaccines because he thought that they were going to poison people. So you're faced with a high level of distrust and a high level of promotion of conspiracy theory. And we need to take this into account when we're discussing how we talk to people about hazard literacy, because we can't assume that people will accept things because science tells them that. And we're we're particularly in the UK. Many of our politicians do not have a science background. They do not necessarily understand science, and you can see in the US that many politicians do not trust scientists, and the consequences of that are more than political. They are they affect people's health and people's lives. Not surprisingly, young people are not happy with this situation. Many people across the world have protested, saying that they are not adequately prepared for the situation that they're facing. The curriculum, what they're taught in school, isn't good enough. People have been striking in schools for a long time, taking lots of civil disobedience, some violent, mostly non-violent protests about what's in the curriculum and what they're being taught. And we know that teachers too are also many teachers in many countries want a different curriculum. They want to teach more about climate change, more about sustainability. Even in the US, 86% of teachers surveyed about 6 years ago thought that climate change should be taught in school, even in some cases though it isn't. Almost over 2/3 of UK teachers wanted to see more teaching about climate change. 70% of the respondents wanted a radical change. Now, often these surveys are surveys of people who are committed to the cause. So sometimes the data here may be higher than if you took all teachers and surveyed everybody. I'll show you a survey that does that in a minute. But while 89% of teachers agreed that UK students should always be taught about climate change, only 18%, 1 in 5, said that they had received adequate training to teach. So we know that teachers say they haven't been trained adequately to teach about these subjects, and this is why our centre is producing teaching materials. In the UK, the climate change has to be taught in geography and science, but no other subject. Geography is not compulsory after the age of 14, so the only climate change, the only sustainability education you have to get is in science, and of course that's a very narrow perspective on what is actually needed. It's nothing like what is actually needed. Now, this survey in the Journal Environmental Education Research was carried out by mainly my colleague Paul Howard-Jones and his son and another person, and what they did was to get a group of schools and a large number of teachers who were taking part in an in-service program, and they gave them all the survey. So it represented people, it sampled people from every secondary school, primary school, every subject. The response rate was about 95%, because they were in a room with these surveys. So we have a much greater understanding, I think, of what the average teacher thinks from these surveys. And they asked people, at what age should children be taught about climate change? At what age should children take part in community-based projects? At what age should people start writing to their Member of Parliament, and so on? So here's maybe the most interesting piece of data. At what age should children participate in civil disobedience around climate change? So Key Stage 1 and Key Stage 2 are primary elementary school. Key Stage 3 and Key Stage 4 are secondary school, high school. And you can see that 20% of the respondents, 20% of teachers across the different schools and different subjects, 1 in 5 said that's the age that people should be taught about civil. Now, if you add all those figures up, that's a lot of teachers who think children should be taking part in civil disobedience. Now, that could be school strikes, it could be people writing to their policymakers and trying to get change, or it could be something more violent. About 40% of teachers said never. Children should never be taking part in civil disobedience, and that points to a sort of a gap between, well, not a gap, but maybe two kinds of teachers. Teachers who think that children should be actively involved in changing society in some way, and teachers who think who think the opposite, that they should not. And that is something that we have to think about if we're trying to think of what a new education should look like for addressing sustainability and climate change and so on. How do we sort of encourage all teachers to support young people in getting involved, if that's what we think should be the case? So when I was asked to do this talk, when I was asked to think about hazard literacy and risk, it reminded me of a paper I'd written about 25 years ago, and I looked back and I found this letter to the editor by an American college lecturer, Glenn Briscoe, who was talking about, he's responding to an article by Paul Slovich, who's written a lot about risk, and he was saying that in the US, the way that risk is taught is not good enough. It means people don't understand ideas about risk. And he was very sort of vociferous about saying how poor risk education was. I hadn't seen this when a colleague and I, Peter Gill, began to talk about the teaching of risk in British schools. We were both ex-teachers. We were both then working at King's College London in maths. I was in science education, teacher education. Peter was in maths, teacher education. And we were thinking, how should risk be taught in schools? What could we do to encourage children to understand issues of risk and probability? And we talked about, and this is 25 years ago. So our sort of ideas have, certainly my ideas have evolved since then. I also discovered at the same recently that in March 1995, Mark Bailey, who was writing his PhD thesis about, he was working with a union in the chemical industry and nuclear industry in the US. And in his thesis, he was talking about how well prepared people were for dealing with the risk they faced in their everyday life. And he mentioned the word, you can see it here, he mentions hazard literacy. And that's the first use of the term that I've found, there may well be more, but that's the first use I've found of the term hazard literacy. Peter and I were talking about, writing our paper, we talked more about risk education. And one of the points that we made was that as a species, we are not very good at estimating risk. We are not very good at working out whether something is more risky than not. We're not very good often at dealing with risk. And I'll give you this example here. So what I've got here is a list of things that if you are 40 years old, you might die from. Anyone here 40 years old? Okay, Piotr, thank you. Now, this year, in your 40th year, you might conceivably die of any of these things here and other things, but I mean, we're going to focus on these. What do you think is the biggest risk to Piotr, and what do you think is the least risk? And if for bonus points, what do you think the chances are? 1 in a million, 1 in 10,000? So I'm going to give you just a minute or so to try and rank those risks to someone who's age 40 and try and work out which you think is the highest risk and which you think is the lowest risk. And then I'll show you the data. So I'm just going to give you a minute to rank them, and you can get a sense of which one you are most likely or least likely to die from when you are 40. A bit morbid, I know, but this is what risk education is sometimes about. Okay, so let's get a sense of what you think. Which one do you think is the most likely cause of death? Piotr, what do you think? It's you at stake here.
I would say an accident on the road.
An accident on the road. I've driven in Seoul. I haven't seen a single accident in the whole day. Okay, thank you. What do you think? Same idea. Okay. Smoking. Smoking. Okay. Okay. So all causes of death, all natural causes, is comes second, an accident and house. Let's put all these up. So number one, smoking 10 cigarettes a day. So if you want to reduce the risk of dying, can't do much about that, although smoking is incorporated in that, or natural causes maybe, not maybe. Influenza, okay. Stay in. Don't drive. Don't go on the road. Leukemia, okay. Playing football, don't play football. Stay in, but don't move. And so on. Being hit by, oh, that's an interesting way of spelling lightning. Being hit by lightning, so we have a 1 in a million chance of being hit by lightning, so in 1 year, it's about 10 million. So that's quite interesting, I think, to give you a sense. So if we sort of think about educating people for risk literacy, for hazard literacy, understanding the data has to be a prime function of hazard literacy education. Understanding how these are calculated, understanding the gender dimension. These are for men only. The difference for gender for women is different. Why is that? So these are all different dimensions of what risk education, risk literacy is about. How have these changed since 2000? These data are from over 25 years ago. How have these changed over time? These are data from England. How are these data different in South Korea, anywhere? So all these, to become even basically literate and therefore able to do something about it depends on your understanding data, and how trustworthy is the data is another issue. And so we can build a curriculum, and we can build maths and science lessons around data, around exercises like this. And one point is, of course, that as you demonstrated, thank you, we're not necessarily as good at it as we should be, even if we're working in the field ourselves. So it's pedagogic exercises like this which we think would be quite helpful. There's the table in the paper that gives you a sense of, and here we have this notion of categorizing risks into moderate, low, and so on and so on. It's also quite a, who decides what low is, who decides what moderate is, and so on. And then a very simple way of thinking about risk in terms of everyday life is how is risk assessed, who assesses risk, what policy, who decides what policy is brought in to minimize risk, what level of risk what do we accept in society. Every medicine will kill somebody, probably, but we assume that it will only kill at most 1 in a million, and therefore that's safe, unless you're that one person in a million. And then how do we manage risk? And there's a balance between the science of risk assessment and the values implicit in risk management. You could assess the risk as being very high and decide to do nothing about it because of the benefits to society, and so on. So, hazard literacy, risk assessment, risk awareness, all these things I think are fascinating in terms of deciding what you might teach to whom, at what age, and in what way. This is another table in the paper, and it looks at this way of classifying risk in terms of observable risk, things that you, like a cable you might trip over, to things which are invisible, viruses, whatever, nuclear radiation, whatever, and in terms of things which are of low, in terms of dread, things that you really are really worried about, things that you are not worried about. So something might be a big risk, but you're not really worried about it. Something might be a high risk and you're very worried about it. Understanding the different types of risk and how we respond to them, and also deciding that who that we have a role in deciding what if something is risky or not. Things are not absolutely risky or not. They are, to some extent, we decide whether something is a greater risk than something else. And then there are other ways of thinking, categorizing, think about negligible risk and high risk, different ways of sort of conceptualizing that, all of which I think would make quite interesting exercises for teachers to use with young people. So if we look now at what we know about climate change education and try and see how we can integrate that with teaching about risk and hazards, this review was carried out, again, it's in Journal Environmental Education Research, carried out by some US colleagues led by Martha Monroe. And they looked at all the research that has been published so far, which seemed to suggest that what effective climate change might look like, and they came up with 4 categories of effective climate change education. And I'll go through each one of these in turn. So the first one is engaging people in what they call deliberative discussion, which means that young people are involved in not just passively listening to people talk, but they're engaged in discussing what the issues are, discussing different points of view, coming to their own opinion about tasks, deciding what they think about something, deciding what they should do about it. And in the consequences of this material here, they are discussing issues that affect their school, and they are then going to sort of come up with a project that will change what people do in school. So this teaching material here might be used to reduce the number of cars that are allowed to come to school and increase the number of bicycles. It might be reducing food waste in the school. It might be reducing the number of lorries, buses parked outside emitting fumes while they're waiting for children to take children home. So it's a sort of an active project that helps people to influence their environment. So interacting with scientists is a second strategy, whether that's online or face-to-face. Some examples of that: this is the Natural History Museum in London, and it's the Darwin Centre, and here people can go and interact with scientists, because for many people they have no interaction with scientists on a day-to-day basis. And it's, if you want to increase people's interest and trust in science and scientists, what better way perhaps to do it than actually bring people in close contact? So maybe part of our hazard literacy education should be bringing together professionals with young people so they can see that they're normal people, that have interests like them, and that they are, they're trustworthy, they are to be believed in. Or you might involve people in citizen science activities, which in many cases, in the early days of citizen science, were just crowdsourcing data, just getting people to collect data for the sake of it, for the benefit of other people. Nowadays, there are different kinds of citizen science, starting from level 1, citizens as just sensors collecting data, to level 4, where people work together to come up with the problems they want to address, and bring in scientists, bring in policymakers, bring in social, people working with the groups in society to try and address those real problems in everyday life, and that is described as extreme citizen science, and is probably the one that we should be aiming for by children of the age 15, 16 are taking part, so they feel that they're able to address the environmental problems that they may come up with. This is the third one. The third effective strategy for addressing climate change is to address misconceptions. We've seen earlier on how prevalent misconceptions are about the environment and health, and we need to directly address them. This activity here There's a colleague who works in with plants in a garden in London, and he realised that young people don't know where their food comes from in many cases. So with the children, he grew tomatoes in a tomato can and corn in a Doritos pack and apples in an apple juice pack, so people could see that their food comes from actual plants. And he's got about 60 or 70. So the fourth one, the final one, is actually involving people in implementing school or community projects. This is a school in China I visited many years ago, a green school. Green schools are very popular in China for a long time. This school on the right is in London, and you can see the young people are taking part in gardening, very active. They've just been given these new yellow gloves by a supermarket who's decided to sponsor the school, so they're all excited they can do some gardening, looking very smart. And examples again in China, this is Haidian Elementary School, experimental school not far from the Botanic Garden in Beijing. And you can see the kind of things that schools are able to do to improve their environment. And I think the important thing about these examples is it shows what can be done. And if one school can do this, then far more schools can do it. And that's the inspiration, I think, for us, is that with strong leadership and use and good resources, schools can do amazing things. And that's what keeps me going, I think, is a realization of what is possible. The schools, take part, not just about curriculum, not about what's in the subject, but they actually take part actively in recycling and reducing and reusing. The quality of the work in the school is absolutely fantastic because the school kids are committed to what they're doing. This is in Denver, Colorado. It's a school, fairly typical school in many ways in terms of the area it serves. But it's one of a group of schools called the Odyssey Schools, and these Odyssey Schools spend their time, focus their entire curriculum about taking people outside the classroom. So they have these learning expeditions, and learning expeditions can be for a short number of hours each day, or they can be residential, and the whole of the curriculum, the whole of the school curriculum revolves around what they do in these expeditions, and it's inspirational. What they do is quite inspirational. We have one example of a school like this in the UK called the XP Academy. And they've reorganised their curriculum, so it's not separate subjects so much as topics and integrated topics. It's a secondary school, it's a high school, and they organise their themes of these topics so that teachers work together, students work together to address big questions over 6 or 12 weeks, almost the complete opposite of what happens in most of the schools. So it can be done with inspired leadership. These things, we can do things differently. And their results are fabulous. The school is oversubscribed many, many times because people look at it and think this is where we want our children to be educated. This is an example of the material produced by the children, and it's in a local park, and it's designed for the public to understand better what the value of pollinators is. Last year I visited this elementary school in Nanjing in China, and it has an amazing leader who's very dynamic, and she decided some years ago that she was going to do something fantastic to commit the school to sustainability. And this is the school garden. This is what you can see when you go behind the school, and you can see every class, and there are lots and lots of classes because it's a big school. Every class has a space that it can grow crops which they can eat and whatever, take home, whatever. And you think, how many schools do you know that have anything like this? And the fact is that the fact that one school can do this suggests that more schools with more materials and more support could do something quite spectacular. This is the school greenhouse. Remember, this is an elementary school. This is their greenhouse. How many schools do you know have a greenhouse that looks anything remotely like that? It's so big, I couldn't capture it all in one photograph. It's just an astonishing example of what can be done with enough investment and enough determination. A little bit more recently, I was in Singapore. This is an experimental school. The government has set up this experimental school so that children can try out new things to do with sustainability. It's a high school. You can see it's a fairly typical school in many ways. And this is their greenhouse. This is their what they're doing, and they're using a greenhouse for more than simply growing things. They're running experiments, so they're trying different lighting conditions to grow seedlings. I was encouraged to plant some seedlings with the mirror here to sort of reflect light to see if the mirror has any impact on these seedlings. So it's quite high quality science education done by young people in their own fantastically equipped school greenhouse. They have a focus on reducing food waste, so they measure the food waste. When people empty their plates every day, they measure the mass of the food, and they try to reduce that on a daily basis. So over a period of time, they're reducing the amount of food waste. Any food that is left over is composted, and it's then composted actually in the school canteen and then taken outside to help grow the crops and things. The school has its own rainforest. Between the buildings there is an area of land which looks like this, which is effectively the same as you get in a rainforest in Singapore. It has its own snake. There is a school snake, which fortunately I didn't see. But some of the parents are worried about it, but of course the risk of a small snake is quite small. So opportunity there for risk awareness. And it is an astonishing place to be. This is their water, little river, little water area. And this is for the children who go here. It provides an opportunity to really engage with sustainability and climate change education in ways that is far superior just to watching a video or watching a PowerPoint, whatever. And I was encouraged to plant a tree, which mitigated for my air miles coming over, I guess. Yeah. So this looks like a science centre, but it's actually a school that near London, near Heathrow Airport. This school has been designed to operate on like a museum in many ways. So yes, it has its own dinosaur. That's a school canteen behind. And that's a school laboratory on the stilts. And you'll notice underneath this large floor area, and in the floor area, the children have high quality, museum quality exhibition spaces where they can curate their own exhibitions in museum style on topics, curriculum topics, bringing in resources from museums, local museums or further away. And they can create topic-based museums. And teachers are using museum pedagogy, using object-based approaches to teaching. And it's based on the US model of museum schools that's been going for 20, 30 years. I think museums offer very good examples of ways in which we can communicate science. This is the Natural History Museum in London, had an exhibition called Our Broken Planet, where curators had picked out specimens that illustrated the challenge facing us in terms of climate change and sustainability. And there were dozens of these in the entire room, and the public were encouraged to respond and say, well, what can you do about it? As an individual, what would you like to see change? What changes could you make to make the world more sustainable? They followed this exhibition up with a new exhibition called Fixing Our Broken Planet. And you can see it's very popular, and it's just in the same location. And again, there are specimens that are brought out of the museum's collections, put on display. And with each one, there is some opportunity to engage, whether it's through an interpretation sign or a video, but also, as well as sort of seeing how the museum is carrying out scientific activity in order to promote sustainability, you are also given an example of what you as a visitor could do. So this one says, amplify your voice by joining an organisation. It gives an example of a real person who's able to influence policymakers by joining an organisation and promoting change. This one is writing to people in power and asking for action. It's an example of someone who's actually done that. So it's meant to inspire people. So museums, I think, are far better sometimes at inspiring people to make change than schools are, even though schools could be far more influential. We sometimes, for reasons I mentioned before, we shy away in school from promoting, getting children to actually do things to make the world a better place, even though many of them would actually want to do that. This is probably the most beautiful museum in the world, certainly one of them. This is Oxford Museum of Natural History, and it contains fabulous examples of specimens, showing how the rich biodiversity of life, but it also has exhibitions encouraging people to take positive action, showing people that the water distribution in the UK is not fair. So museums, I think, offer us examples of ways in which we can promote science that encourage social change. So what I've tried to do in this talk is to do several things. One is to show how my sort of think about risk has evolved to some extent, has now been incorporated into thinking about climate change and environmental education, to show there are examples around the world of schools that are doing things very differently, inspirational examples, mainly driven by dynamic school leadership but supported by teachers, children and parents who are trying to do things differently. And more importantly, I hope I've shown you that we need to do things differently. We cannot carry on doing things the same because it's failed, and we cannot carry on failing because time is running out. Thank you very much. So,